Ionic bonds, covalent bonds, both of them chemical bonds. How are they made? What's the difference? Watch, you'll see.
For our first Survey of Chemistry project, we'll be covering the topics of bonding and Lewis structures. We will also cover the subtopics of ionic and covalent bonds and what makes them different, along with electronegativity and polarity.
Bonding. Bonding is the joining of two atoms in a stable arrangement. In bonding, elements gain, lose, or share electrons. Ionic bonds result from the transfer of electrons from one to another. Covalent bonds result between the sharing of electrons between two atoms.
So what elements form which types of bonds? Covalent bonds form between two nonmetals or between a metalloid and a nonmetal. Ionic bonds form between a metal on the left side of the periodic table and a nonmetal on the right side of the periodic table. In order to understand the difference between ionic and covalent bonds, we must explain electronegativity. Electronegativity is a measure of an atom's attraction for electrons in a bond. This is the chart that must be used to determine the electronegativity of each element. As you can see, electronegativity increases up a column and across a row. Here's an example. According to the chart, the electronegativity of hydrogen is 2.1, and the electronegativity of oxygen is 3.5. Therefore, the electronegativity difference is 1.4. The electronegativity difference determines bond type. A bond between hydrogen and oxygen would therefore be polar covalent. Nonpolar. Electrons are equally shared. Polar covalent. Electrons are unequally shared. Now that we understand bonding, let's talk Lewis structures. Here are the 3 general rules to follow when drawing Lewis structures. For the purpose of creativity, we have decided to build Lewis structures instead of draw them. Each person represents the element of the sign they are holding, and the joining of arms represents bonding. The first Lewis structure we will be building is of CH4, methane.
I'm carbon.
Carbon has 4 valence electrons and forms 4 bonds.
I'm hydrogen.
I'm hydrogen too.
I'm hydrogen.
And I'm hydrogen. Each hydrogen has 1 valence electron and forms 1 bond. Together we form a molecule of methane, or CH4. Now, referring back to our electronegativity chart, we must find the electronegativities of hydrogen and carbon. In this molecule, carbon has the greatest electronegativity. The electronegativity difference between carbon and hydrogen is 0.4. Referring back to our electronegativity difference chart, we can conclude that an electronegativity difference of 0.4 is less than 0.5 units, indicating nonpolar bonds. Due to this low electronegativity difference, the electrons are equally shared. Therefore, although carbon has the strongest electronegativity, it does not pull in the hydrogens. CH4, or methane, is a nonpolar molecule. Here is another Lewis structure of CH4. As you can see, there are no lone pairs and 4 bonds. Let's talk molecular shape. Here we used a ball and stick kit to show the tetrahedral shape of the CH4, or methane, molecule. Next, we are building the Lewis structure of H2O, water.
Hello. I'm oxygen.
Oxygen has 6 valence electrons.
Hi. I'm hydrogen. Hi, I'm hydrogen.
Each hydrogen has one valence electron. Now we must refer back to our electronegativity chart to find the electronegativities of hydrogen and oxygen. In this molecule, oxygen has the greatest electronegativity. The electronegativity difference between oxygen and hydrogen is 1.4. Now referring back to our electronegativity difference table, we can conclude that an electronegativity difference of 1.4 falls between 0.5 and 1.9. This indicates polar covalent bonds. Due to oxygen's strong electronegativity, it pulls on the two hydrogens. It is also important to remember that oxygen has two lone pairs. H2O is a polar covalent molecule. Here is another Lewis structure of H2O. Oxygen forms two bonds and has two lone pairs. Once again, we used a ball and stick kit. An H2O molecule has a bent shape, with the two hydrogens bending downward. The next Lewis structure we are building is of CaF2, calcium fluoride.
I'm calcium.
Calcium has two valence electrons and forms two bonds.
And fluorine.
I'm fluorine.
Each fluorine has 7 valence electrons. It is also important to remember that in this Lewis structure, each fluorine has 3 lone pairs. Now we must check our electronegativity chart to find the electronegativities of fluorine and calcium. In this molecule, fluorine has the greatest electronegativity. The electronegativity difference between fluorine and calcium is 3. Now we will refer back to our electronegativity difference table, where you can see that an electronegativity of 3 is greater than 1.9 units. This electronegativity difference indicates ionic bonds. Electrons are transferred from the less electronegative element, in this case from calcium. Calcium fluoride has ionic bonds. Here is another Lewis structure of calcium fluoride. Each fluorine has 3 lone pairs. The next Lewis structure we are building is NaCl, sodium chloride.
So, I'm chlorine, I'm sodium.
Sodium has 1 valence electron and no lone pairs. Chlorine has 7 valence electrons, and in this Lewis structure, it would have 3 lone pairs. Now we must refer back to the electronegativity chart to find the electronegativities of sodium and chlorine. In this molecule, chlorine has the greatest electronegativity. The electronegativity difference between chlorine and sodium is 2.1. Referring back to our table of electronegativity difference, we can conclude that an electronegativity difference of 2.1 units is greater than 1.9 units. This electronegativity difference indicates an ionic bond. Therefore, the electrons are transferred from the less electronegative element to the more electronegative element. In this case, they are transferred to chlorine. Sodium chloride has an ionic bond. Here is another Lewis structure of sodium chloride. Chlorine has 3 lone pairs and 1 bond is formed. And that concludes our project. Thank you for watching.
To make covalent bonds with shared electrons, they're covalent bonds. Not a transfer, instead they share